morning. Today we are working on CO58, continuing to work with those polygons. Today we are doing I can determine whether polygons are congruent, similar, or neither. What does it mean if they are congruent? Think about congruent angles, congruent sides. What did that mean to be congruent? Jimena? They're all equal. So congruent polygons are going to be all the same measurements. They are going to be identical. They will be exactly the same. So congruent polygons are polygons that are the same shape and size. All sides and angles are congruent. They equal the same thing. They look identical. So an example. I have my angles A, B, C, and D, and angles X, W, X, Y, and Z. So listing my corresponding sides. Why did I put them at the angles? I see. So listing the corresponding sides, I'm going to do my segment for each side. So my AB is congruent. That's what that symbol means. AB is congruent with WX. BC is congruent with XY. CD is congruent with YZ. And that leaves DA is congruent with ZW. The sides are all the same. If it is a congruent polygons, all the side measurements are the same. They are congruent. Make sense? Okay. So I am going to erase so I can scroll up. Now we have similar polygons. Similar polygons are not congruent. Congruent means they're equal sizes. What do you think they're going to be if they are similar? What do you think, Madeline? Not some are the same and some are different. Good guess though, Amanda. That's exactly it. Congruent is same shape, same size. Similar is same shape, different size. Hello, the skate. So she was at a swim meet this morning and didn't know if she would make it back to school or not. Perfect. Thank you. Bye. Okay, so similar polygons are polygons that are same shape, but different sizes. Angles are congruent but sides are proportional. So it is getting bigger or smaller at the same rate. So remember, those proportions are like equivalent fractions. You're multiplying or dividing each side by the same number to make it proportionate. So an example would be, so my angles, so if I have A, B, C, angle A is proportionate to angle X. Angle B is proportionate to angle Y. And angle C is proportionate to angle Z. So the angles are the same degree measurement. We're just making it bigger, or we're growing it bigger or shrinking it down at the same rate. So our sides are obviously not, they are not the same measurement. So it is not congruent, but our angle measurements tell us that, yep, it is proportionate, it is similar, because our angles are the same. So if I put side measurements on here, I might say I'm making up measurements. So if these were our lengths, I would say that AB over XY, we could see that as the same. AB is 8, XY is 4. We have, you know what, let me put the numbers down below. So AB over XY is 8 over 4. BC over YZ is 14 over 7. And then we have AC or CA over XZ would be 18 over 9. Right, you see how I got those numbers? No. I've got AB over XY. Oh, yeah, I see. So 8 over 4. Then I have BC over YZ, which is 14 over 7. And I have AC over XZ, which is 18 over 9. So I matched up my sides and I made my proportions. What did I do to go from 8 to 4? Zelda?
You subtracted 4?
Nope. When we work with proportions, it is not adding or subtracting. What was that, Kim? How did I go from 8 to 4? I don't subtract with proportions. What do I do? What did I divide by? I divided by 2. How did I go from 14 to 7? Divided by 2. How did I go from 18 to 9? Divided by 2. Another way to look at it, if we don't know what we're multiplying or dividing by to see if it is proportionate, we take 8 divided by 4 is 2. 14 divided by 7 is 2. 18 divided by 9 is 2. We can see the top divided by the bottom gives us the same answer for all 3 sides. So we know that it shrunk down proportionately. So we know it's proportionate, it must be a similar polygons. So in order to know for a fact, you have to do every single side. Did they all shrink down or grow at the same rate? Divide the top by the bottom. Marina, as a Any questions on that one? So let's look at our bottom. Determine whether the polygons are congruent. They're identical measurements. Are they similar? They shrunk or grew at a proportionate rate, or neither. They're not congruent, they're not similar, they are neither. So let's look at our first two polygons, those triangles. Are they congruent? No. So we know that it's not congruent because we have different numbers. So what do I have to do to see if they are similar? Liam,
Divide.
what am I going to divide?
12 divided by, oh wait, I'll just give you the answer.
No, tell me.
12 divided by 3.
I have to match them up. Does the 12 side match up with the 3 side? No. I want to match it up and make my fractions to know what I'm dividing by. We're not going to guess right away, is it dividing by all the same things? So you jumped ahead a step, Liam. What we're going to do is we're going to line it up. 12 over 4. What am I going to put the 15 over? Over the 5. I'm matching up my sides. And then 9 over the 3.
Oh, yeah, I did.
So we're going to match up our sides first, because you will have side numbers that you can't figure out in your head. So I want us to know the process. What do we do when we get those numbers that we don't know how to work with? So match up your sides. So you're going to have, it's 3 sides. You should have 3 proportions. Let's see, are they all proportionate to each other? 12 divided by 4 is what?
3.
15 divided by 5 is?
3.
9 divided by 3 is?
3.
Are these two similar polygons?
Yes.
Why, Ava?
Well, they kind of just like look the same and they're both right angles.
We don't ever go by looks.
They're both
How did we prove that they are similar?
because they all have angles.
They all divide by 3. So I shrunk it down the exact same way. I proved it. I don't ever say they look similar, because we could have something that's 2.5 and not a 3 for a side. It's going to look very close. But if we're not given, then if we don't know for a fact that it's proportionate, we can't say it is for a fact similar polygons. We have to prove it. You have to show what you divide each of the sides by, what their divided number is, that they are identical numbers. Does that make sense? Let's look at our next one. Are they congruent?
No. No.
Well, here's some yeses and some no.
Wait, what? Yeah.
Are they congruent is the question.
No.
Show me your thumbs. Ruby, why are you saying no?
Because
They're flipped. We've got 6 and a 22. We've got 22 and a 6. So, Marina, why are you saying yes?
Because they have the exact same measurements. It's just tilted upside down.
Can we, with shapes, flip them?
Yeah.
We can. So Ruby's right. It's flipped. We can flip it back up. We're going to match up the 6 with the 6. That 19 with the 19, 19 with the 19, and the 22 with the 22. You can flip that polygon up and say, oh yeah, if I flip it, it is identical. So it is totally fine to rotate and to flip, because we're not changing the polygon at all. We're just turning it. So we're not changing that polygon. So yes, they are congruent. That makes sense, Ruby? Yeah, we didn't know we could do that, but now that we do, that's why it's not a homework problem. That's why it's part of the lesson. We know that we can rotate, we can flip, and see if they are congruent. So yes, this one was similar. This one is congruent, because we can rotate it up. and flip it. Okay?
Don't they all,
What?
won't they all be divided by 2 as well?
Yeah, so when something is congruent,
Oh, you
it's going to be, well, it would be 22 over 22, 19 over 19, 19 over 19, 6 over 6. So no, they can't all be divided by 2. They all go down to 1. We know that they are congruent polygons if they all go down to 1. 6 divided by 6. 22 divided by 22, 19 divided by 19, 19 divided by 19. Do you see that? So you know that they are congruent if they all go down to 1. So let's look at our work page. Top directions say draw and label each pair of figures. Make your figures as accurate as possible. So you are going to have to draw and label because we don't ever say, well, they look the same. We have to show that they are the same. We have to show they're congruent. We have to show they are not congruent. Okay, so you have to draw them and label. The label is important. So if we're going to similar, we have to make sure they are proportionate. The middle section says determine whether the polygons are congruent, similar, or neither. Explain how you know. Don't trust your eyes. The figures may not be drawn to scale. You have to use the numbers given to prove it. So when it says explain how you know, you have to show that work to prove it. They are all proportional because they all divide down to this number. Or they are not proportional because this one divided down to this number, this side divided down to this number. Okay, so you have to show how you know. And then time for review. Our test is next week. Practice test will be Wednesday, real test Thursday. So we have our last objective will be Monday. We will have review on Tuesday, practice test Wednesday, real test Thursday. So this review is important. Make sure you know all of these vocab words and you can answer those. Any questions on today's work? When you are finished with the homework, if you have retakes, if you have approved practice work, or you have practice work that needs to be corrected, it will be a retake time because it is Friday. So we combined doing a lesson and our retakes on the same day. So use your time wisely. This is a no talking time because I will have some people testing. So no talking. If you have questions on the homework, come see me. If you are watching this at home, I hope you are well. I hope to see you soon. Have a wonderful day.